Góðan daginn allir, velkomin á þennan föstudags fyrirlestur og við erum hérna Malin De Siilva sem ætlar að fara yfir confidential computing og við munum þakka honum fyrir sinn tíma. Þannig að hello Malin, thank you for giving us your time and going through this confidential computing. So I'll just give you the torch and you can start.
Yeah, sure. Let me start by sharing my screen. Good. Okay, so welcome everyone for this session. We will be speaking about confidential computing. My name is Malin De Siilva and I'm Microsoft MVP for Azure. And I also work as a senior consultant at Capgemini Netherlands right now. So before going into more detail, we just have a look at what we are going to discuss about. We'll speak a little bit about the data lifecycle and how these are protected. And then we'll speak about what is confidential computing and what are the options that Azure has. And we'll go a little bit deep onto two of them. One is the confidential VMs and the other is a confidential ledger, which is still in a maturing stage by its own. So data lifecycle, if you look at the data that we have in today's applications, I think more than 99% of the applications do interact with the data. It can be a front-end application that users are filling data. It can be a back-end API that's transforming the data, or it can be a batch application that's processing and transforming, or there can be some other multiple types of applications, you can name it. So basically, whenever data comes in, we need to work quite a lot on with this data to ensure these are the data that we really want. We might have validations, for example, someone's ID card or something like that. And they needs to be validated that these are correct information. So that means from the point that the user enters data till the stage we define them as validated, it goes through quite a bit of a process. That's how it is. And then the privacy is a concern. So basically, if you have someone's personal data, you need to make them secure, restrict them from anyone else accessing. So privacy is a big concern. And then on top of this, you need to make analytical workloads run. So if you need, you might anonymize some of the data and just get the properties, for example, a person's age, gender, things like that, and then bind with some other data and make some analytical decisions that will be helping the organization in future. And then on top of all this, there are regulations and compliance that you have to comply to. Depending on the place you have in EU, you have quite a lot. And if you take another countries like Australia, Korea, they have their own regulatory and compliance requirements that need to be done. And then there's things like untrusted collaborations. For example, there might be instances where you'll be sharing data with someone else. For example, if we look at some sort of Facebook app, you can implement it in your own website. So when you are signing, you are using the single sign-on option. So that data shall come from Facebook to our application. So that's sort of an untrusted collaboration. So likewise, so it's carrying out the data, personal data of a person. So likewise, there are quite a lot of things that are happening in data. So focus on data, on how to protect them and how to secure them has been a big topic over the years, and it has quite a lot matured. Now, how matured is it? We have three stages in data that systems can integrate and interact with them. First one is data at rest. When you store the data in a database, if you store it in a SQL or a file-based data system, that will be stored as encrypted. So the people who are accessing it from outside will not be able to access them without the correct authentication that are provided. So even though there's a system failure in the system itself, even when they access it, there's no meaning. Same happens with our good old Windows. Now it has the BitLocker feature, so the data will be encrypted and protected. Even if you lose the laptop, you won't have an issue because the data will not be accessible. Simple as that. And then another thing is data in transit. Now imagine someone is filling a form on website. So there is a front-end application, and then there is an API that is connecting to it, and then there's a database. So the whole transit process from the front end, actually starts with the front end, which is the user's browser. From the browser to API to the database, this whole process is defined as transit, and now it's secured by transport layer security. It has TLS 1.2 and 1.3 recently, I guess. So that data is encrypted. They will be using HTTPS, so none of the information will be accessible by plain text. And then the last one is data in use. Now, this is not an area that has been evolved quite a lot. This became to focus more around 2018. That's where the confidential computing starts to evolve. So what happens is, once we have all this data, we will be making certain shape-ups within this data. So one of the example was, as I said, validations. Once someone stores data in somewhere else, there can be a background process which is running it and validating it. Then they might be changing them to something else. So there are quite a lot of things that can happen. Now, how can this data in use can be secured has been a question. Because if you look at something that can do this sort of a batch process or something like that, there are plenty of options on Azure itself. We have Azure Batch Service, and then you can use Azure Function timer triggers, and there are quite a lot of other options that you can use within Azure itself. But if this is running inside a VM, now the process will run inside a VM, so that means that users, an administrator or someone who logs into that system during the process will have access to this data. This is not a very highly liked scenario, but it is something that people and organizations are right now looking into it, because it can cause a few trouble if someone has access to those VMs or something like that. Now, who are the people can impact this data in use? So there can be malicious insiders or privileged admins. As you know, if we are running a simple scheduler inside a VM, if an admin connects to it, that person can see the console output itself, and also can trace the network logs and things like that to see what are the data that the application is taking in. And then there are some hackers who can access the hypervisor. So usually there's a virtualization layer on top of the operating system, the host operating system. That virtualization layer has a guest operating system. So if someone gets access to the hypervisor, the data can be accessed. These are not very simple things like you see in movies, but these are possible scenarios that can be come with the hackers and everyone's evolving. And then there are third parties who can access the data without consent. So if you look at some like advertising, something, sharing information, there can be people who can access this information at a very unnoticed stage. So the key here is the focus to data in use came in was that it just takes a little bit of carelessness to cause a huge damage. It's not something going to happen every day, but this is the reason it might become a future compliance requirement. Right now it is not in many of the regulatory compliance policies as well. And then let's look at what is confidential computing. So as I earlier said, confidential computing came into live around 2018. And the idea behind it is having running the computations within a hardware-based trusted execution environment. That is TEE. Let me take the answer. So that is TEE. So the computation itself runs within a hardware-based trusted environment. So how does it happen? We look at one of the existing examples that is available. So if you look at a Azure Kubernetes cluster, if we take a confidential computing node, what we can have is we have the host OS and the CPU, hypervisor, and the operating system, normal, the hierarchy itself. And then there are containers that are running on top of Docker or something like that. So what happens is each container gets part of CPU that's allocated to it. And that CPU is usually shared, right? So if we have two containers, we will be using CPU shared by DSA. But what confidential computing does is it only allows a part of the CPU that runs this container node itself, but it's not allowing anyone else to run that part of the CPU. So it is secured within a enclave, which is set. The code and data interacts, and it cannot be accessed from outside anyone. So that's what it's called a hardware-based trusted execution environment. So basically, it's the memory, the CPU, and the code itself are secured such that it cannot be accessed from anyone outside. And also then verifiable assurance for data integrity, code integrity, and the data confidentiality. Those can be provided by the service provider itself. Right, so now the confidential computing has been very evolving topic within all the cloud providers. So as in Azure, so Azure Confidential Computing has different options for hosting these confidential computing features. It all starts with the virtual machines. We will see what are the options available there. But there are certain DCA, ECA virtual machines available in the AMD processor. These are newly available. And then also there are some Intel virtual machines with the DC SV2 and DC SV3 and DC SV3. And then there's limited preview of NCC NVIDIA VMs by the time of this slide deck was prepared, which was in the Ignite 2022. And then for the containers, there's Enclave Intel SGX nodes on AKS, and then confidential VM worker nodes on AKS. So the virtual machines that are running are of the confidential VMs that are available. And then also, if you want more something like container instance, then confidential containers on Azure Container Instance is also available in a limited preview right now. And not just that, there are multiple services that are already available. So you have SQL Server Infrastructure as a Service on confidential VMs that's available. And then SQL Server always encrypted with secure enclaves. It's also available. And the Azure Virtual Disks on confidential VMs, which is on public preview. And Azure Managed CCF is also there. What we are going to see is more of a Azure Confidential Ledger that is also generally available, but I think I have access to a preview version right now. So we will see how it works in the demo. Right, so I will go through to the portal and show you how to create a confidential VM. Now I'm in this Azure portal. I believe we all are familiar with it. And I have a resource group created here. And then I will go to the marketplace. To see what are the available options for virtual machines. Oh. Let me go from virtual machines. This is much easier. And I will go to create a new Azure virtual machine. I select one of my available subscriptions, select the resource group. I will not physically create this one, so I will use some name here. Right. I will leave EC2S as it is, and availability zones you can configure whatever you need. And if you go to security type, it has multiple options. Standard has the basic level of security for the virtual machines, and then trusted launch virtual machines. What it is? So there are certain. If you look at your normal virtual machines, you can see quite a lot of applications are launched on the startup. So what this allows is these VMs ensure the launch is secured within virtual machines itself. So it ensures that they have this virtual trusted platform module. When a VM starts, it protects any other malicious processes getting started with that. And then we have the confidential virtual machines, and it say on top of the trusted launch. So not just trusted launch, confidential virtual machines offer higher confidentiality and integrity guaranteed with hardware-based trusted execution environment that we say. Now, these are not available in all the regions. For example, if I select something like ES2S2, if you go to security type, you can see it's disabled. So it's available in limited regions right now. And then you can select all the VM architecture, stuff like that. And if you go to sizes, we can add a filter here. Yeah, let me see. Let me just go back here. East-US, we have security selected. Oh, we have to select confidential virtual machines, and then we can select the images. What are the images we need? We have this option of creating them, and then we can see all the sizes. Right. So when we come here, I think we will find it here. Security. Oh. Right, so if we come here, we can see DC series designed to protect the confidentiality and integrity of code and data for general purpose workloads. And then EC series, which is for the memory intensive workloads. And then we have all the other sizes not available and incompatible with confidential virtual machines and everything listed below. So if we go with the DC series, you can see DC2 ADS V5, DC2 AS underscore V5, and so on. Have quite a lot of options here. So you can select one of these options. As you can see, it starts with 8 GB RAM and 2 vCPUs and about 149 in this region. And the same with the EC series, it starts with a little bit because it's memory intensive and has higher RAM and so on. So if you select this, you can give a username here. I give something that I am not going to create this. So, for some reason it's stuck. That's fine. Now we'll go to the next tab. We have the option for selecting disks. It has this encryption at host and the confidential compute encryption. So you can enable it and it will allow everything you need to happen. So there from that you have the key management options. You can use the platform manage key and so on, multiple options there. And you can have all the other features as it is. Okay, so let's go back to the slides. Now, one thing I spoke and we saw something like it was Enclave. It has like Enclave, but it's Enclave. So what is an enclave? So an enclave is a protected memory region that provides confidentiality for the data and code execution. You saw that in earlier slide. We have the data and code encrypted and secured within the region itself. So that is called an enclave. It is an instance of a trusted execution environment which usually is secured by hardware, for example, Intel SGX. So the key concept behind this, it's being secured at the hardware level with the security keys. Right. So now we have quite a lot of applications that we are already running, and what will happen if we want to migrate them to confidential computing program spectrum? Now, if you look at the slide deck down below, you have the option for easier to onboard legacy apps, larger TCB, the total cost benefit, and then we have this side, the custom solutions and granular security control, so on. So if you have any old applications and you need to migrate them, the option for confidential VMs and AKS node pools are available there. So you can host them in confidential VMs. Otherwise, you can containerize them and put them into AKS node pools. So that option is there. Why do we need them? There can be confidential GPU, large GPU requirements. There can be AI and ML needs. So for them, you might need these confidential GPUs. And then the SQL Server and AVD, Azure Virtual Disk for the confidential VMs also available if you're using for the solution. And then, so this is AKS itself, Azure Kubernetes Service, running with on top of the confidential VMs. And if you need confidential container instances as it is, you can lift and shift to the serverless containers here very easily. And then internal SGX or SSL and the partner solutions are available. So these are for the applications that are already running, but if you feel or if you get into a situation where you need to run them on confidential instances itself. But if you are creating new applications, there are open enclave aware apps right now available. So you have the open enclave SDK, which utilize the hardware-based trusted execution environment with custom C++ code. There are wrappers available for C#, which I have seen. There should be ones for Java and other applications as well. And then the confidential consortium framework that's also available. It's the OSS framework for secure multi-party compute and data. And then there are multiple built for purpose services, for example, Azure Key Vault, Manage HSM, Microsoft Azure Attestation, SQL, always encrypted, and other features that we show in the previous slide. Okay, so we saw different types of confidential virtual machines. And if you look at AMD VMs, you can see the custom VM machine itself has an encrypted memory region on top of the hypervisor, OS, and device drivers. That's going to secure the memory and the application code execution itself. So the way how AMD and Intel handles it is different, because in AMD VMs you have this region that you can encrypt and have within as a box itself secured inside. But in Intel, what has is it has enclaves that's going to be separately executed when for the execution and the return. So what happens is you will have a partition app and you create an enclave and do the attestation and call trusted. So the execution happens on a different app enclave. So the business logic can rely without going into this enclave itself. Likewise. So you can see more details in this if we go to a deep dive. Right. So now one thing that's pretty much trending there and pretty much interesting for me, I found was this confidential ledger. Now I will go with the detailed introduction that is available here. So, and then we'll explain it a little bit more and show a demonstration of how it's working. So what is Azure Confidential Ledger? It is a newly and highly secure service for managing sensitive data records. It runs exclusively on the hardware-backed secure enclaves, a heavily monitored and isolated runtime environment, which keeps potential attackers at bay. So furthermore, it runs on a minimalistic trusted computing base, which ensures that no one, even Microsoft, is above the ledger. So what happens here is it's secured to the best possible situations, and it's a confidential ledger, and it's based on the blockchains itself. So if you want to create a blockchain that is secure by the hardware itself, then the Azure confidential computing option is available here. So it's not just ledger, but it's using the nodes within the confidential computing. Now what happens is this is exposed via REST API, so it's easy. Anyone with REST API knowledge can access it and see how it works. And there are certificate-based authentication for owner role and Azure Active Directory authentication and Azure role-based access control. I will show them in a demo when we are doing it. And then how these are stored, it's stored in a blob storage and in a storage account. But that storage account is not accessible to outside, so no one gets access to that. So let's see a demo on this. It's a very interesting thing that's coming on. So how do I have already created one, but let me create one and show you how to do it. So this confidential ledger is available here. I can go create. Right. I have my subscription and the resource group selected, and I need to give a name. So this needs to be a unique name right now. I will do something like this, because you will be getting a public URL for this. And then we have the region. Right now, only 3 regions are available: East US, South Central US, and West Europe. And then the ledger type. What is ledger type? So the private ledgers are there and the public ledgers are there. So public ledgers are for the regular data storage. Private ledgers are for the encrypted data storage. The data are stored encrypted itself, even within the enclaves itself. Now, if you create it under public or private, you cannot change it after you create the ledger itself. So that's something you need to be aware of. And the security, you have the Azure AD based users. You can give ledger role. These are Azure role-based access control options. Right now, only 3 are available: the administrator, contributor, and the reader. So if you need the administrator, you need to define, and then if you need someone to write them, then you can add them, and the reader option. So I believe the manager identities and everything will come later. And then you can have the certificate-based access. So you can present a certificate and give access here. Others are basic stuff, so I'm not going to create that one. I will go to the one that I have already created and show you how does it work. Now, as you can see, I have this instance called demo1, and it creates a ledger endpoint, which is demo1.confidential-ledger.azure.com. That's the ledger endpoint. And then there's identity service endpoint. You can use, I haven't used it, might be useful. And then the ledger type, I have created this as a private ledger. And here we have the access control. So normally RBAC access control, ideally they will come in here when things are available. So yeah. So in the role assignments, I might see the roles, and I should be able to add a role assignment later if I need. right? So, okay. Now, what's interesting, important from what you see here is you have these authorized ledger users, AAD-based users. So you have client libraries and all the information that you need, and then cert-based users. So the examples are here as well. So for the AAD-based users, the Azure Active Directory-based users, they can use the managed identity itself. So if you are signed into Visual Studio when you are developing, you can easily use it. I will show how to use it here. Right. So let me go to my VM. Right. I have this sample project created here. It's just a console application. As you can see, only the program.cs is available. But I have set up a few NuGet packages in this one. Let me go and show them. So I have installed Azure Identity and Azure Security Confidential Ledger. These two NuGet packages are there. And what I'm going to do is I have this program.cs class. That's all I need. I have imported these using statements. And then we have this ledger URI, demo1.confidential-ledger.azure.com. That's the same thing you find in if you just come in here. So, and then what I'm trying to do here is I'm trying to get a message from the console once it runs. And then I'm going to create this thing called confidential ledger client. Right? So what's happening here is in my Visual Studio itself, I have enabled it to use my Azure, my user account. So it will be not prompting for username and password. So it's pre-authenticated. It runs here. And likewise, if you are running this on a other instance, you can usually assign the system assign managed identity in that application to access this with the same code. So I only need the URI, and I'm giving the default Azure credentials, which is my credentials that will be shared later. And then we have this concept of collection. You need to define a collection where this will be put in. So where are you going to put in? That will be defined in the collection. So that's how the ledger is structured. It's a little bit different. It's not a little bit, it's a lot different to what you see in a normal relationship databases. So we will define a collection. And here in the post operation, what I'm doing is I'm doing a post operation. I'm waiting until it's completed. So it says that indicates whether the method should wait until the operation fully completes. Yes. And I'm going to create the content, the message itself, whatever I'm going to type here. Let's run it through till this and show how it works. So I will enter a message test2. So this is in so the instance I think that I have is in preview mode. That's why it's a little late. Otherwise, it will be much faster here because it's doing all the authentication and so on. So in the post operation, we get the message has completed as true and get an ID. So that's the called transaction ID, right? So I will go through the code a little bit. What we have is we get this transaction ID. So how does a ledger work? It's append in the record. So that's how blockchain works. It takes a set of transactions and create a block and create a chain of it. That's the concept of it. So what it's going to do is it's going to have this transaction appended to the place where it needs to go. That's the way how it's working. So we are getting this transaction ID itself. I can enter the transaction ID, and I can get all the ledger entries within that collection itself, and I will be printing them. So if I run this again, As you can see, the collection ID is COL3, content test is there, and test2 that I added just is here. If I add something else right now, it will get appended here. I will run something and give something like ABC, something like that. And the message is printed. So right now, every time this is authenticated, that's why it's a little bit delayed. But usually we are going to bootstrap that authentication in the beginning, so it won't be that fast. So you can see this one is added, and we have transaction ID and the collection ID itself. So if you need, you can add into a different collection ID. I will put something like column. Name doesn't matter, just a collection ID need to be there. I will enter a random message here. And this collection will ideally only have this transaction itself. Yeah, see. So it appended the transaction and the collection and the content is here. That's how it's done. Yeah, so that's about what I have here for the presentation. It's an interesting area that you can explore and get to know, because surely the confidential computing will come in much heavily in future, and I see the organizations having required to use them. It's evolved quite a lot, and we hope it will evolve quite much more, but it will be a good thing to know them in advance. Any questions you can ask?
Yeah, any questions from you guys there? No questions?
Okay. Yeah, sure. If you have any questions, just let me know. I'm available on LinkedIn or Facebook or anywhere, so you can ask any questions. Right. Thanks so much.
Yeah, thank you. Yeah, bye-bye.
Bye-bye.